So we got y plus 6 greater than or equal to 10, right? So the first thing we're going to do is just treat this as an equation. And so to get y in its own, how would we get rid of the plus 6? Let's just subtract 6 from both sides, right? That's all you got to do. So what would you have on the left now? You have y because, no, you have y because 6 minus 6 is 0, so you just have y. What's 10 minus 6? 10 minus 6 is 4, right? Now, because we subtracted from both sides, the inequality stays in the same direction. It's only when we divide by a negative that we change the direction, and we went over that a little bit. Now, y greater than or equal to 4 is kind of like saying y represents all numbers that are all numbers greater than 4 comma but including 4 also. Okay, so that's what that means. So even though it's a very simple little expression, inequality, y greater than or equal to 4, it actually means a lot. It implies a lot. Okay, and like it's hard in English to narrow it down. You kind of need to write this long sentence to represent this little bit of math here, right? Because y equals 4 was easy. That was just, the y is just one number. That's an equality. This is an inequality. Okay? So this is an equation. So this was an equation. We saw those, right? That was an equation. But this is an inequality. Okay? And an inequality is a lot more complicated than just a simple equation. It means a lot more. Here's a number line, okay? And I'll just put 0 right here in the middle. You can draw that, right? You can draw a straight line. You can put 0 here. You okay with that? Yeah? Draw a straight line, put 0 there. That's all we got to do. Okay, and now it goes 1, 2, 3, 4. There's 4, right? 5, 6, 7, 8, 9. 5, 6, 7. Right, here's 3, here's 2. Okay, here's 1. Okay, you can mark off some numbers on that, can't you? Alright, are you confused so far? Is this okay? This is just a number line. Have you seen a number line before? Okay, cool. Okay, so y represents all numbers greater than 4, including 4. What I want you to do is just tell me a number that y could represent. Okay, let's read it again. Y represents all numbers greater than 4, including 4. So 9, that's a number that's greater than 4. Okay, yeah, 9, that'll work, right? Give me another number that's greater than 4. 10 is greater than 4. Good, that's another number. What other number can y represent? 8, yeah, there's 8. Anything else? Yeah. Okay, give me a decimal that y could represent. 9.1, and that's about here. 9.1. Give me another decimal that y could represent. 6.1, good. 6.1. Anything else? 5.1. There you go, 5.1. Give me another decimal. 7.2. Okay, 7.2. Can y represent 2? Why not? It's not greater than 4. Could y represent 0? No. How about negative 10? Could y be negative 10? Is negative 10 greater than 4? No. So how can I, on the number line, so how about 3? Can y represent 3? 3.5? 3.9? How about 4? Yeah, because it's including 4. It's greater than or equal to 4. Y is greater than or equal to 4. So 4 is included. How about 4.1? That's there. That's good. 4 point anything, in fact, right? Now tell me, how can I represent all of the decimals that Y can be? Well, but what I'm asking is, now forget about brackets and all that nonsense. Look, every time you shouted out a point, we made a dot. Okay? Didn't we? Okay. How can I show all of the dots? What would it look like if I filled in every single possible number that Y could be? Yeah, it'd be lots of dots, wouldn't it? Like that, wouldn't it? So that's why the line is kind of filled in, right? Now, so that's the first concept is, yes, Y includes 4. And sometimes you have this kind of big filled in dot to show that. The other times you have this bracket that has a square part on it, right? And that right at the 4. And that shows that 4 is included. So with inequalities, these square brackets mean included, and these parentheses mean not included. Okay? So that's some of the notation that we'll just need to remember. That's included, that's not included, right? Okay. So how about this? Like, Y is greater than or equal to 4. Tell me, could it be more than 10? Could it be 100? Could it be 1,000,000? Okay, how far can it go? Infinity, positive infinity, right? But we never really get to positive infinity. Like, so it goes on and on and on and on towards positive infinity. But can we ever reach infinity? No. So the Y can be on and 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 on forever, but it can never actually reach infinity. Because that's a theoretical concept. It's not actually a number, right? The reason infinity is not a number, by the way, what's infinity plus 2?
I'll never be able to know.
It's infinity, right? So the reason infinity is not a number is because you can write this, and this doesn't make any sense. Like, what number added to 2 gives the same number back? Only infinity, which that's why infinity is not a number. Anyway, point is, we have all of these dots, right? So Y, you can write like this as well. It's from 4 onwards, right? So Y represents a whole range of numbers. 1,000,000, 2,000,000, 10,000,000, 1,000,000,000, 1,000,000,000,000. It represents all those numbers. Agreed? But not 3, not 2, not 3.9. We went over that, right? Okay, so that's the graph, and that's all it means. Now, there's such a thing as intervals, okay? So we're going to write an interval. Now, an interval looks like this. You give the minimum number in the group and the maximum number in the group. And then you use brackets or parentheses. So, if you take all these numbers here that go from 4 all the way towards positive infinity, what's the minimum number in this group? 4. Good. Is 4 included as part of this group of numbers? Okay, so should we use square brackets or parentheses?
Square bracket.
Okay, so you just do that. Oops, so you just do that. Is positive infinity... sorry, what's the maximum number? Positive infinity, good. And should we use square brackets or parentheses?
Parentheses.
Why?
No, square brackets because it's included.
No, you got to use not included because you can never reach infinity. So that's why we use parentheses. You never get there. You cannot enclose infinity because you'll never reach there, type of thing. So anyway, so that's the interval notation for this inequality, right? Good deal.